So in this plant physiology, so we are going to the one of the most important smallest chapter in your second year, that is enzymes. So what are the enzymes? So first of all, you know the reactions in organisms. So there are two types of reactions: physical reaction and another one chemical reaction. Physical reactions and chemical reaction. In that physical reactions, only that shape of the substance is changed. So for example, ice, that ice is converts into converting into water. So that is simply physical change. But in physical change or physical reactions, so there is no breaking or making of the chemical bonds. But in chemical reaction, those chemical bonds are maybe undergoes to breakdown or maybe making of the new bonds. Hence that reactants. Those reactants are converts into products. So those are the chemical reaction. So those chemical reactions are rate of that reaction. The rate of the reaction is based on the substance or reactants. And also another chemical is required. That chemical is called catalyst. That catalyst can speed up the rate of chemical reaction. So catalyst is also another chemical. That catalyst is also another chemical. That chemical does not involve in chemical reaction, but can speed up the rate of reaction. That cannot involve in chemical reaction, that can speed up the rate of reaction. That is called catalyst. So those catalysts are involved in chemical reactions within the laboratory. But what are enzymes? You know that one in our body, plant body or animal body, containing large number of biomolecules. So those biomolecules are also undergoes to the chemical reactions. Those biomolecules are also undergoes to chemical reactions. Chemical reactions. The chemical reactions which takes place within the organisms. The chemical reactions which takes place within the organisms. So those are simply called biochemical reactions. The chemical reactions takes place within the organisms. Those are simply called biochemical reactions. So those biochemical reactions are also said to be metabolism. Biochemical reactions inko name enti ante metabolism, are also called metabolic activities, are also metabolic pathways. The metabolic pathways are biochemical reactions or metabolic activities are also carried out with the help of special catalysts. So those catalysts are called enzymes. Those catalysts are called enzymes. So enzymes are biocatalysts. Enzymes are biocatalysts. They involved in biochemical reactions. Enzymes are the biocatalysts. They are involved in biochemical reactions. So those biochemical reactions are metabolic activities are carried out with the help of enzymes. So generally those enzymes are made up of proteins. Generally, enzymes are made up of proteins, but all proteins are not as enzymes. Some of that proteins, those are act as enzymes. How that proteins are act as enzymes? You can see in your first year biomolecules chapter. So types of proteins based on their structure. There are 4 types of proteins based on their structure: primary structure, secondary structure, and tertiary structure, and quaternary structure. When we are observing that primary linear structure, secondary helical in structure, but tertiary structure is most important. That tertiary structure having that polypeptide chain or protein molecule having the large number of enfoldings. It looks like N-terminal, C-terminal. It looks like halo woolen ball. So that is halo woolen ball. So that is looks like halo woolen ball. So when we are observing this type of tertiary structure of the protein, the tertiary structure of the protein having gaps, those gaps are crevices or pockets. Pockets are also said to be clefts. Those clefts are crevices or pockets. So those are act as active sites. Those are active sites. So due to presence of those active sites, especially in the tertiary structure of the protein, so they acquiring catalytic property. So those protein enzymes are nothing but proteins. They having special active sites and having the catalytic property. Such type of tertiary structures of the protein should be act as enzymes. The tertiary structure of the protein should be act as enzymes. Mari enzymes are proteins. All proteins are act as enzymes, nothing. So some of the non-proteinous enzymes are also present. So some of that non-proteinous enzyme. So the non-proteinous enzymes, are called ribozymes. Ribosome kadu, ribozymes. So these ribozymes, how that ribozymes are obtained? Those ribozymes are obtained from to the nucleic acids. Ribozymes are obtained from nucleic acids like RNA. And one type of RNA, that RNA is 23S rRNA. So the 23S rRNA should be act as ribozyme. That is act as a ribozyme. So that is the non-proteinous enzyme. This enzyme is mainly helps in formation of the peptide bonds during the protein synthesis. Formation of the peptide bonds during that protein synthesis. That is the non-proteinous enzymes. So how that enzymes are useful in the chemical reactions? For that purpose, you can go to the one by one. So first of all, enzymatic activity. You can see the enzymatic activity. So what is the main function of the enzyme? The enzymes can speed up the rate of reaction. Enzymes can speed up the rate of reaction. How that enzymes can speed up the rate of reaction? You can see that one example, that carbon dioxide is dissolved in water to form into H2CO3, carbonic acid. Carbonic acid. In the absence of enzyme, so within 1 hour, only 200 molecules of the carbonic acid is formed. Only 200 molecules से form होता है यदि without enzyme. मरे यदि same reaction with enzyme. What is that enzyme? Carbonic anhydrase. So in the presence of enzyme, carbonic anhydrase, so 6 lakh molecules 6 lakhs of molecules per second. చూడండి, imaginary, unimaginary. So that enzyme can speed up the rate of reaction. So without enzyme అనుకోండి, ఒక్క అవర్లో కేవలం 200 molecules ఫామ్ అవుతాయి. But in the presence of enzyme carbonic anhydrase, in the presence of enzyme carbonic anhydrase, 6 lakhs molecules are formed within the 1 second. So that is the activity of the enzyme activity. Next you can see the enzymatic activity, the activity of the enzyme. Activity of enzyme. So you can see the activity of the enzyme. So the substance which undergoes to the enzymatic activity, that is simply called substrate. The substance like that in your chemistry, reactants. ఆ రియాక్టెంట్స్ని ఇక్కడ ఏమని చెబుతామంటే సింపుల్గా సబ్స్ట్రేట్ అంటే సింపుల్లీ డినోటింగ్ దట్ ఎస్. సో ఆఫ్టర్ దట్ enzymatic activity, the substrate is converting into product. So P stands for product. But in this one, E means enzyme. E means enzyme. S substrate, P product, E enzyme. Okay na? So substrate is converting into product. So after that, what is that enzymatic activity? So how that enzymes act upon the substrate to conversion of the product, you can see this one. So during this time, that substrate is combined with the enzyme to form into enzyme substrate complex. Enzyme substrate complex. What happened during this enzyme substrate complex? Enzyme substrate complex, imagine this one. So this is the substrate. So this one is the enzyme. So during this time, that enzyme containing active sites, that enzyme having the active sites, the tertiary structure of the protein should be active sites. So during this complex formation, that active sites of an enzyme is occupy the substrate molecules. So this is the substrate, this one is the enzyme. The active sites of an enzyme is attached to the substrate molecule to form into enzyme substrate complex. After onwards, with the help of enzymatic activity, that enzyme substrate complex is converting into enzyme product complex. Enzyme product complex. What happened that substrate can, how that substrate can converting into product? ఈ సబ్స్ట్రేట్ ప్రోడక్ట్గా ఎలా మారింది అని కనుక చూస్తే, దట్ ఎంజైమ్, ద యాక్టివ్ సైట్స్ ఆఫ్ ఎన్ ఎంజైమ్ ఈజ్ యాక్ట్ అపాన్ ద సబ్స్ట్రేట్ మాలిక్యూల్స్, so that enzyme can break up the chemical bonds or maybe make up the new chemical bonds. Hence that substrate is converting into product. So now itself that substrate is converts into product. There is no change in their enzyme. సో ఎంజైమ్లో ఏ చేంజ్ ఉండదు, సబ్స్ట్రేట్ దేనిగా మారిపోయింది, ప్రోడక్ట్గా మారిపోయింది. సో దట్ ఇంటర్మీడియట్ స్టేజెస్ ఆర్ కాల్డ్ ట్రాన్సిషన్ స్టేజ్ ఆర్ ట్రాన్సిషన్ స్టేట్. Those intermediate complexes are formed during that enzymatic activity when that substrate is converting into product. Substrate product ga మారేటప్పుడు intermediate compounds ఉంటాయిగా, those are called in transition state. After onwards, so that substrate is separate or enzyme is separate from to the substrate, will conduct the same reaction, will performing the same reaction, only that product is releasing outside. That product is the releasing outside. So this is the activity of an enzyme. So how that S means substrate, P means product, intermediate compounds, that is the transition state. So during this stage, that substrate is combined with the enzyme to form into enzyme substrate complex. Such a time that active sites of an enzyme attach it to the substrate molecule. After of that enzymatic activity, and that enzyme active sites act upon the substrate molecule that can break the chemical bonds or maybe formation of the new chemical bonds. Hence that substrate is converting into product, another intermediate compound, enzyme product complex. Finally, that enzyme separate from to the product will performing the same reaction in many time. Okay, so that is the enzymatic activity. It was explained by two important theories. One theory is called lock and key hypothesis. Lock and key hypothesis, and another one is induced fit theory. Induced fit hypothesis. Induced fit hypothesis. So first one is the lock and key hypothesis. It was proposed by Emil Fischer. So that lock and key hypothesis was proposed by Emil Fischer. According to this lock and key theory, so suitable key can open the suitable lock. Like that also, suitable enzyme can act upon the suitable substrate. Hence that substrate is converting into product. It is also enzyme specificity. That means one type of enzyme is always act upon only one type of substrate. One type of enzyme is act upon only one type of substrate. So like this also, suitable key can open the suitable lock. Like that, so suitable enzyme can act upon the suitable substrate. That is lock and key hypothesis. And second one, induced fit hypothesis. It was proposed by Daniel E. Koshland. So according to induced fit theory, so that substrate molecule does not undergoes to any change during that induced fit theory, but the active sites of an enzyme, for example, these are the, so this is the enzyme, but this is these are the substrate shape. Idemo substrate shape, idemo enzyme, but these are the active sites. Even the good active sites. The active sites of an enzyme can undergo to change to fit into substrate molecule, to fit into the substrate molecule. That shape of the substrate does not undergo to any change. Only the active sites of an enzyme are undergoes to change to fit into substrate molecule, to fit into the substrate molecule. That's why it is called induced change. Induced fit hypothesis was proposed by Daniel E. Koshland. Okay, that is the induced fit hypothesis. 2 marks question in your IP. That is also there in our IP textbook. So next, you can go to the how that enzymes are working on the enzymatic activity. So enzymes ante those are act as biocatalysts. Those can be speed up the rate of reaction. So enzymes main work ante those can be speed up the rate of reaction. Those are speed up rate of reaction. So those are speed up the rate of reaction. How is it possible? You know that when so the transition state, the substrate is converting into product. When that substrate is converting into product, that can be overcome the one energy barrier. What is that energy barrier? Transition state. The minimum amount of energy is required that substrate is converting into product for that enzyme. So that energy is called activation energy. activation energy. So the amount of energy is required to conversion of the substrate into product. Later the free energy which is required to conversion of the substrate into product, that energy is simply called activation energy. So that activation energy is useful to conversion of the substrate into product to overcome the energy barrier, that is called transition state. అంటే సబ్స్ట్రేట్ ప్రోడక్ట్గా మారాలి అంటే మధ్యలో ఒక ఎనర్జీ బ్యారియర్ ఉంది, దట్ ఈస్ ద ట్రాన్సిషన్ స్టేట్. ఆ ట్రాన్సిషన్ స్టేట్ని దాటితేనే ఆ సబ్స్ట్రేట్ ప్రోడక్ట్గా మారిపోతుంది. మరి దాటాలంటే కొంత ఎనర్జీ కావాలి, దట్ ఎనర్జీ ఈజ్ కాల్డ్ యాక్టివేషన్ ఎనర్జీ. ద అమౌంట్ ఆఫ్ ద ఫ్రీ ఎనర్జీ ఈజ్ రిక్వైర్డ్ టు కన్వర్షన్ ఆఫ్ ద సబ్స్ట్రేట్ ఇంటూ product is called activation energy, or the amount of the minimum amount of energy is required that substrate is enter into the transition state, that is also activation energy. Mari what is the benefit of enzyme? Enzyme can decreases the required activation energy. Enzymes can decreases activation energy and speed up the AE means activation energy and speed up the rate of reaction. How is it possible? You can explain with the help of one of the graph. You know that one x-axis and y-axis. So in this one required activation energy, rate of reaction, velocity of the enzyme activity, rate of reaction. Imagine this one, this is the P, sorry, this is the S. S means substrate, this one is the P. So this is substrate, this one is the product. That product is lower than the substrate now, that's why it is the exothermic reaction. So exothermic reaction, ఇది చాలా సార్లు ఎగ్జామ్లో ఇచ్చారు, నీట్ అండ్ ఎంసెట్లో. This diagram is most important. That is also there in +1 book and our IPE second year textbook. సో ఇప్పుడు ఈ సబ్స్ట్రేట్ ప్రోడక్ట్గా మారాలి అంటే ఇది ప్రోడక్ట్ అనుకో. సో దిస్ మచ్ ఆఫ్ యాక్టివేషన్ ఎనర్జీ ఈజ్ రిక్వైర్డ్. దిస్ ఈజ్ ద లెవెల్ ఆఫ్ ద సబ్స్ట్రేట్. దిస్ మచ్ ఆఫ్ యాక్టివేషన్ ఎనర్జీ ఈజ్ రిక్వైర్డ్. సో దిస్ రేంజ్ ఈజ్ ద transition state. This is the transition state. That energy barrier is a transition state. అంటే ఈ సబ్స్ట్రేట్ ఈ ట్రాన్సిషన్ స్టేట్కి మారితే కానీ దేనిగా మారదు, ప్రోడక్ట్గా మారదు. మరి ప్రోడక్ట్గా మారాలంటే దిస్ మచ్ ఆఫ్ యాక్టివేషన్ ఎనర్జీ విత్ ఎంజైమ్ ఆర్ వితౌట్ ఎంజైమ్ అంటే వితౌట్ ఎంజైమ్. వితౌట్ ఎంజైమ్ ఇఫ్ మేబీ ఎంజైమ్ ఈజ్ అవైలబుల్, if that enzyme is available only, so this much of activation energy, this much of activation energy, this much of activation energy is required with enzyme. With enzyme. So this much of activation energy is required. చూడండి that energy requirement, this is also activation transition state. సో చూడండి దీని నుంచి ఇది ఫాస్ట్గా వెళ్ళిపోతుంది, ఇది లేట్ అయిపోతుంది. అంటే ద ఎంజైమ్స్ కెన్ డిక్రీజెస్ ద రిక్వైర్డ్ యాక్టివేషన్ ఎనర్జీ అండ్ స్పీడ్ అప్ ద రేట్ ఆఫ్ రియాక్షన్. సో దిస్ గ్రాఫ్ ఈస్ ద మోస్ట్ ఇంపార్టెంట్. సో వితౌట్ activation energy, this activation energy is required without enzyme. This much of activation energy is required with enzyme. అంటే enzymes are lowering the required activation energy and speed up the rate of reaction. And speed up the rate of reaction. So that is the enzymatic activity. So this is the first topic in enzymes for in your IPE. So 2020 మార్చిలో 4 మార్క్స్కి క్వశ్చన్ వచ్చిందమ్మా. సో మొన్న 2020లో 4 మార్క్స్కి వచ్చింది క్వశ్చన్ ఐపీఈలో. నెక్స్ట్ సో వీఆర్ గోయింగ్ టు ద అనదర్ టాపిక్, దట్ ఈస్ ఫ్యాక్టర్స్. ద ఫ్యాక్టర్స్ ఎఫెక్టింగ్ ద రేట్ ఆఫ్ ఎంజైమాటిక్ యాక్టివిటీ. So the factors which affects the rate of enzymatic activity, rate of enzymatic activity. So there are three important factors. So first one is temperature. So second one pH, and third one concentration of the substrate. Concentration of the substrate. So next, rate of enzymatic activity. Speed up the rate of enzymatic activity. You can see the first one. So temperature. So if the temperature increases, the rate of enzymatic activity is also increases. Rate of enzyme activity is also increases. So how is it? So you can see that graph like this also. First of all, enzymatic activity is increased with increase in the temperature. Then after decreases more than how many degrees? 40 degrees. So you can see the three important bits in enzymatic rate of temperature on enzymatic activity. So first of all, in low temperature, those enzymes are inactive. In low temperature, the enzymes are inactive. So this property is useful to the preservation of our foodstuffs, preservation of the food materials, vegetables, fruits within the refrigerators. In refrigerators, low temperature, those enzymes which are present within the foodstuffs or vegetables, or maybe any pathogenic microbes present in the foodstuffs, those enzymes all enzymes are inactive. All enzymes are inactive in low temperature. And second important one, the optimum temperature. So second one, the optimum temperature. The optimum temperature to enzymatic activity is 25 to 30 degrees. The 25 to 30 degrees temperature is highly suitable to enzymatic activity. And third one, in every 10 degrees increase in the temperature, according to the tumbler, left hand tumbler, every 10 degrees increase in temperature, the enzymatic activity is doubles. Enzymatic activity is doubles. And the fourth bit is in more than 40 degrees, so the enzymes are nothing but proteins. Proteins are aggregation of amino acids, they having peptide bonds. So those peptide bonds are break down. So enzymes are undergoes to denaturation and they break down. So enzymes are undergoes to denaturation in high temperature, more than 40 degrees. Okay. Next, we are going to the another one, pH. So if maybe pH is increases, same like that also, same graph, bell shape. So if the pH is increases, the rate of enzymatic activity is also first increases, then after will decreases. So pH. So pH means the H plus ion concentration within the solution is simply called pH. If the pH is increases, the rate of enzymatic activity is also increases. After onwards, that will be decreases. So it is also graph in bell shape. But remembering only one important point that is not there in your book. So most of the enzymes are active in neutral pH. Most of the enzymes are active in neutral pH. Some enzymes are active in acidic pH, some are in alkaline pH, but most of the enzymes are active in neutral pH. Okay. So in the last important one, concentration of the substrate. Concentration of substrate. So if the concentration of the substrate is increases, the rate of enzymatic activity, is also increases up to maximum level, that is simply called Vmax. So after onwards, when the enzymatic activity is reached to the maximum level, there is no further increase in the enzymatic activity because all those active sites in those enzymes are participate into the enzymatic reaction. So the velocity of the enzymatic activity, so concentration of the substrate. So the concentration, if the concentration of the substrate is increases, the rate of enzymatic activity, the velocity of the enzymatic activity is also increases in maximum level. That maximum level is called Vmax. That is called Vmax. Vmax means that enzymatic activity is in maximum, highest level. So there is no further increase in the enzymatic activity or velocity of the enzyme activity because all enzymes containing active sites all are participate into the enzymatic activity. So in this one, if that so enzymatic activity will reach to the half of the Vmax, so such a time when that enzymatic velocity or the enzymatic activity will reach to half of the Vmax, half of the maximum velocity, so that is simply called half of the Vmax, that is simply called Km. Km means, so Km means Michaelis and Menton constant. So Michaelis and Menton constant. So that Km value is equal to Vmax by 2. What is the meaning of Km? Michaelis and Menton constant. That is the Km is equal to Michaelis and Menton constant. That Km value is depends upon the concentration of the substrate. What is Km value? So when that enzymatic activity is reached to the maximum velocity, the concentration of the substrate, important 2 must bit and also neat MSET bit. So the concentration of the substrate, when that enzymatic activity is reached to the half of the maximum velocity, ante enzyme activity full ga unnappudu Vmax antamra, దానిలో ఎంజైమాటిక్ Vmaxలో సగానికి వచ్చినప్పుడు ఎంతైతే సబ్స్ట్రేట్ కాన్సన్ట్రేషన్ ఉంటుందో దట్ ఈస్ కాల్డ్ Michaelis Menton constant. Simple formula, Km is equal to Vmax by 2. Km is equal to Vmax by 2. That is simply called Michaelis and Menton constant. So that Km value is depends upon the concentration of the substrate. There is another out of syllabus bit, that is turnover number. Turnover number means so one enzyme molecule లేదా 1 mole of enzyme within 1 minute the number of substrate molecules are converting into products. That is simply called turnover number. So turnover number of the enzyme means the amount, the number of substrate molecules are converts into products with the help of 1 mole of the enzyme within 1 minute. That number of substrate molecules is called turnover number. So this is the So this is the factors affecting the rate of enzymatic activity. So there is once again you can see the rate of enzymatic activities depend upon the temperature. If maybe temperature increases, the rate of enzymatic activity is also increases. So 4 important bits చూడొచ్చు దీనిలో. సో లో టెంపరేచర్లో ఎంజైమ్స్ ఇన్యాక్టివ్గా ఉంటాయి, మనం రిఫ్రిజిరేటర్లో వాడేది అదే. ఆప్టిమమ్ టెంపరేచర్ అంటే ఎంజైమ్స్ బాగా పనిచేసేది 25 to 30 degrees. అది అకార్డింగ్ టు లెఫ్ట్ హ్యాండ్ తంబ్లా. సో ఎవ్రీ 10 degrees increase the enzymatic activity is doubles. So more than 40 degrees those enzymes are undergoes to denaturation. But some of the enzyme, some of the bacteria, primitive archaebacteria, those are called thermoacidophils. Those are called thermoacidophils. Those bacteria are the enzymes present in those bacteria are withstand in high temperature 80 to 90 degrees. That is some exceptions. Some of the bacteria which are live in hot sulfur springs, those are called thermoacidophils. Those bacteria containing enzymes, those enzymes are highly thermal resistance. Those are highly resistant to temperature up to 80 to 90 degrees. The remaining enzymes more than 40 degrees they undergoes to denaturation. And also concentration of substrate. If the concentration of the substrate is increases, the rate of enzymatic activity is also increases, because all active sites of an enzyme are undergoes to enzymatic activity. But when that enzymatic activity reach to the maximum, that is called Vmax. So when that enzymatic activity will reach to the half to the maximum velocity, that is simply called Km. Km means Michaelis-Menten constant. The concentration of the substrate when that enzymatic activity is half to the maximum velocity, simply Km is equal to Vmax by 2. That is the factors affecting the rate of enzymatic activity. Next we are going to another topic, enzyme inhibitors.